Okay, good morning, everyone, and welcome to the Bell webinar. Thanks for joining the Bell webinar series for 2023 today. Today's webinar is Flow, an in-depth look at Bell's database management system and its novel capabilities for analysis scripts containerization. The webinar will include a discussion on Jupyter Notebooks and a Q&A session. So please enter your questions into the chat and we'll read them out during the Q&A session. Today's presenter is Dr. Roma Schusterman, who's the Chief Technology Officer at Bell. And I will go ahead and turn it over to him.
Morning. As Corinne mentioned previously, my name is Roma Schusterman, and I'm happy to present today our new advances in Flow. So Flow is the core of Bell products. It's workflows and the database management system, and it allows to store data from EEG recordings and then perform multiple analysis on these recordings. All data is traced also in Flow. And then let's start from the overview of today's presentation. So initially, I'll provide a brief overview of Bell System 1, and then Flow we'll go step by step from concept, licensing and authentication, data organization, and then through these topics, and then we'll end by reviewing capabilities of Jupyter Notebooks, and then actually how from this idea of prototyping with Jupyter Notebooks, how we can containerize these notebooks and transfer them into workflows. So some topics of Flow were covered in a previous webinar, mostly different workflows like Sorcerer ERP. So I'll just mention them briefly, and otherwise the rest of the topics would be relatively different from the previous webinar. So this is Bell System 1. So Bell is offering streaming and acquisition of data from 130 and 280 EEG channels. It's acquired by a Bell Amp. It's a battery-powered wireless amplifier that the data control to the amplifier is via client computer. From any client computer, user can access Bell Amp and record and review data. And during the acquisition, data is pushed to Flow. This is our workflow and data management system. Data is further stored in Flow, so for future reviews, analysis, and traceability. So what is Flow? So Flow is it's a workflow and database management system. It can be, we support two options, either on Amazon AWS or as a physical computer that can be in any lab. Flow can stream data from Bell products like Bell Amplifier or Bell Wisp. It can multiple amplifier and Wisp can be connected to Flow. Once data is pushed to Flow, a user have an interface where a user can access flow through this interface, and the user can access from any client computer, and our database at Flow is agnostic to the operational system, so it can be accessed from any computer. From there, a user can perform different workflow analysis on recorded data. Among them is a source error, event-related potential analysis, and review data in Bellevue review. And also, we connected the option of notebooks where a user can perform different analysis and that not covered by current existing workflows. So so we have a subscription model to Flow, and once purchased, lab gets a number of flows, and if purchase Sorcerer, then it gets number of licenses for Sorcerer. I think it's 10 flows goes as a default, and because of this licensing model, it can be very easily extended. And for us, it will just modifying a number of licenses on a Flow server side, on the licensing server side that is on our end. So a Flow server is periodically querying a license server to ensure how many licenses are activated, and via internet. But even in case if it's not connected to the internet, Flow will operate smoothly and will query a licensing server anytime, whenever the next connection to the internet was performed. So we have 3 different access tiers to Flow. The most control have administrator, admin license. They can manage data, they can build, generate new experiments and users, and they can also have control licenses and remote access to Flow. Next tier is lab managers that can perform almost all the operations as admin can, but without the controlling licenses and remote access. And then we also introduced a additional tier, access tier as a researcher. So this is it has the most limit. It has this tier has access only to defined set of experiments, and this is primarily intended for collaborators when lab wants to share specific set of recordings with a collaborator, but not the access to the full database. So within Flow, data is organized by experiments, and within experiments, data is organized by participants and by within each participant, there are a number of recordings that belong to each participant. So we also introduced a number of features to have for audit trail to perform. We record actions, and we monitor downloads of data, deletion of data, and any other workflows that were completed or errors that appeared in a flow. So, for example, workflow history tab, it consists of a different list of all workflows that were performed on a flow, and it has a file name that it was performed on. It has a type of the workflow, a participant on what participant would perform, who ran this flow, status, and date. And even by status, for example, we have it was successfully done or it was some error. In case of error, we can extend this tab further and we can see what type of error what happened here. And this just helped to investigate further. So from the error that appears here, it seems that the EDF file that was uploaded to Flow was not of the proper format. Some information was missing, and that's why the ELP was not able to run. So this is not in a very user-friendly interface here for errors, but if users experience some problems, they can share this information with Bell and will help to debug what's the most reason for this error specific. Also, as I mentioned, we have records for downloads or deletion of files. And lastly, we have also tab for tracing any errors that flow related. So this is example of how it looks like. So we are working hardly to eliminate all errors. And as you can see here, this is last error recorded here was about 6 months ago. We did not observe since error, but still we cannot exclude option of future errors and bugs. That's where we keep track of these errors. And again, users can share later data extend tab and share data with Bell. So for us, it will be easier and faster to respond to specific error. Now, so we discussed data management and data handling. Now it's let's move to the data analysis part. So we implemented right now at Bell 3 different workflows that we released to customers. It's a ERP workflow where user can run on a segmented MFF file. They can put different settings here, filters. They can define time before and after the TTL event. They can remove bad segments, and they can apply a different reference. And so this is a tab that opens and runs on the MFF file. From output from this, user can observe in a Bell view, and then analysis of the same file can be later performed in a Sorcerer or a source localization package. So all these were covered in depth in the previous Flow webinar. So I won't stop much here on these workflows, but rather just mention that stay tuned in the next in Q1 2024, we're adding also a additional workflow need. This is a sleep staging workflow. So now these workflows allow to do very robust analysis, and but they are still limited. We're working to enhance our set of workflows that we're supporting, but due to development time and time that we spend on verification, validation of each product, it just takes time. So to bypass this, we decided to add to Flow ability of to communicate with MFF files with Jupyter Notebooks. Jupyter Notebooks is a Python-based environment that it combines actually three things in itself. It's a cell-based, and cells can have notes or commentaries. It has computational cells where a user can perform any calculations, and it has output cells where for visualization. So this is just a very powerful tool for presenting analysis projects. So let's see how it works. So this is Bell Flow. I'm logging as an admin. So we already discussed here is our experiments. There is a list of experiments. Within each experiment, data is organized by participant, and then we can have access to each file, and the files can be downloaded, files can be queried information, files can be deleted, and then on each work file, depends on its type, we can perform different workflows. So additional brief review here that I mentioned but did not focus too much previously. This is a remote access tab that, and again, this appears on my site and here in Flow only because I logged as an admin. For lab managers and researchers, they don't see this tab. And this tab allows if remote access is activated, this allows a Bell access this Flow server, and for two reasons. One reason, if there is any bugs and errors on Flow that we may have access to test this and query the backend. And additionally, this is also allows us to perform updates and upgrades to push it to user. once this remote access is disabled, no one has access and to flow, and data is stored in your lab and perfectly safe. So let's go to this notebook. So in the notebooks, we implemented two folders. One is a workspace. It's a personal workspace. This is where each user has its own workspace, and they can have different notebooks and work here. And there is also a shared space. That's where everyone who has access to Flow has access to the same folder in a shared space. So let's just see this one example of notebook. And this is a notebook we downloaded. It's an open source. We downloaded it from a GitHub repository. And this is one of a number of notebooks that as part of this package of open source high-performance tool for automated sleep staging, which was published in eLife a few years ago. So this specific notebooks allows to perform spindles detection. Spindles are oscillatory activity somewhere between 11 to 15 hertz that appears during sleep, and it's associated with a thalamocortical interaction. So, and then just what I did, I just uploaded this notebook into my shared space, and just let's see. You see, this is there are tabs and cells that have pure description and notes that can consist what a description of the next step or reasoning what is done. There are tabs or and cells where actually user is for calculation and coding. Here, what I did, I just connected this notebook that it will read and analyze data from one of our sleep recordings that were performed by WISP. And let's see, I'll try to rerun it, started from the very beginning and run it all together. I hope it will work and there will be no bugs as usually during presentations. So once cells is processing, it shows a star. Once processing done, it shows as a number. So yeah, everything works smooth. So in the in two first cells we connected, we imported libraries for further analysis, and then we successfully connected to a MFF file in Flow. It shows information to which file it was connected, all the file info, and then from here and on, this is this is just a original notebook that perform this spindle detection. So it detects files within chunks. It performs a spindle detection in a chunks of 15 to 30 seconds. It initially shows raw data, then it performs spectrogram, and then it has three different parameters to detect spindles. Once all these three parameters are crossed, and this is the decision function. It's just a union of these three parameters, and then it shows data and shows this detected spindles within these files. So again, this is not a scientific talk or how specifically to analyze detect spindles, but this is rather just to emphasize the flexibility and the beauty of notebooks, that it can has a number of different sections that user can present any comments and thoughts, and then analysis and visualization and output of this analysis. From here, user can take and even further, they can download this as a, for example, as a HTML file, and then let me open it. I just download this HTML, and this is now user can share this with collaborator, with anyone who has no access to Flow or any Jupyter notebook. And even I think from my personal perspective, this is a very good structure for doing some intermediate presentation to the lab of how analysis was done, what results were achieved, what worked, what didn't work. So we're just very fast. Once you have some analysis, you can actually output it and have it as a presentation. Now, so this is a very flexible tool. It allows to perform any computation that Python capable. You can import different Python packages. You can it will also on the backend we support MNE package, so it's already imported on the backend. So it's very handy and nice. So, but then we decided to take additional step. So once the notebook is fully developed and users are happy with performance, there is no need anymore to run this analysis or modify any parameters. So then from here, the next step that we wanted, we just added here. We wanted to switch from this notebook prototype actually to a workflow that right now we're working on the ability to containerize this notebook scripts, and we're coming with this new feature in Q1 next year. So we're just from this file. So the basic idea we wanted to make is that once the analysis is established, it can be added to Flow as a workflow. And then you can run this notebook, not going into notebook menu, but from this tab of workflows that you can click on the workflow tab on each file, and then you can run this new workflow. So for doing this, we're extending a little bit, and if there are any input parameters to the workflow, if there is, for example, if user if workflow requires a modification of high pass or low pass filter, or if there is any choice of different electrode montages, so user can define this in a dedicated cell within a notebook as a very first cell, and Bell, we will be parsing this input, and we will convert this input into a user interface that will appear later for the specific workflow. And then, for example, once the notebook is completed and it has a defined input within this first cell, we're adding this ability that the user can choose the specific notebook. The user will define a workflow name for this analysis within this notebook. And then just by generating workflow, clicking on this generating workflow, this will convert and immediately add this specific workflow into a list of workflows. So from here on, once it's generated, you don't have anymore to go to these notebooks, but rather you can do this and run this spindle detection from the list of workflows. So I think that's all from my side.
Great presentation, Roma. We do have a couple of questions that have come into the chat. And I want to encourage everyone to go ahead and put questions into the chat. Does the Flow user have to be able to write code in order to set up and use workflow?
So workflows that are existing here, there is zero code. User can run Sorcerer, Bellevue, and all other workflows that are connected here without any single line of code. And once they convert this notebook into workflow, there is also no anymore coding, just single click, one click button.
Great. The next question is about Jupyter Notebooks. They use Python and MNE. What about MATLAB?
So we are working on also adding MATLAB notebooks. I think they call it Livebook. They have slightly different configuration, and sometimes mid next year we should come out with this feature as well.
Great. Let's see. In the next question, can the output of notebooks be archived in Flow under the same experiment or participant folder?
Yes, it's a good question. Output from a notebook can be stored in Flow near the same MFF file within, yep.
Do you need to be connected to the internet to use Jupyter Notebook or Flow?
If you're accessing Flow from a client computer, that it has to be either on the same network or it has to be accessed from internet. So, for example, right now I'm accessing a Flow instance that's running on AWS. Without internet, I won't be able to access it. But if the Flow is located in a lab, so user just need to be on the same network. And once Flow is accessed, Jupyter notebooks do not require any additional connection. This is just part of the Flow.
Great. Well, I just want to remind everyone that this webinar will be it's being recorded and it will be available on the website if people want to review it at another time. And just ask if we have any more questions. But I think that might be it. And I just want to go ahead and thank everyone for coming. Thank you, Roma. And thanks for joining the Bell webinar series today.
And yes, thank you. And please send us more questions if you have.